Hello everyone, this project demo is for my course EEL6512, Image Processing and Computer Vision. In this project, I've realized human facial expression recognition on iOS device, which has a front camera to detect human face. Then, we use the features of human face, such as eyes position, smiling or not, to control graphical user interface. Here's the demo for finished project. This is a very simple demo on facial expression control. I just created a gallery which has two photos and used the face feature, smiling or not, to switch between these two photos. As you can see, if I'm smiling, the current photo will change to another one. If I'm not smiling, the current photo will remain unchanged. If I'm keeping a smiling face, the photo will change all the time. In many cases, it is inconvenient to use fingers to touch on the screen to operate the device. Try to imagine that this device is a wearable device without any large screen such as a watch, glasses. Operation based on touching actions becomes difficult. Facial expression recognition control will make life easier since we can free our hands out of the screen and all we need is a front camera to detect human face. That's a demo. The project demo is based on the amazing framework core image provided by Apple. Thanks Apple for providing the particular example, SquareCam, for core image. The following part is for the code and realization. Welcome to the realization part of this presentation. We'll continue to talk about human facial expression recognition on iOS device. Here is the data transmission map for this application. We use the front camera on iPhone to take real-time video and put the data stream of this video into the data buffer. Then do expression recognition on this buffered data stream, say different frames of photos. Finally, we exploit face features to control some of the graphical user interface elements. This is the top-level design for this application. Face recognition on smartphone is based on the front camera on the phone. We need this front camera to capture human face in real time and analyze each frame of the recorded video. From each frame, we may extract one static picture from front camera. After extracting, we may implement specific algorithm to analyze this single frame picture for sake of capturing human facial expression. In order to avoid the situation that real-time stream takes up too much memory and time to be dealt with, it is better for us to establish a video stream buffer to temporarily store a specific number of frames. Then we need an entry to this buffer to capture frames of images. Finally, we need to do some processing on these images and pass the result parameters to the main view controller for the sake of requesting the main view controller to have some response based on different facial expressions. As long as we get a result from face recognition, which contains blinking eye, smiling such user actions, main view elements are unable to respond to the specific action. For example, when user blinks their eyes, the screen turns into black. Following this top-level design, we may create various kinds of applications based on the face recognition framework. This is a video stream recording model. The video recording part is realized by the method of setup AV capture. In this method, we first choose a video device. User may choose whether they will use the front camera or back camera. After the input device is set, we need to create a class, which named by video data output to make the video data output. We implement the method EV capture video data output to execute video recording. Then we need to create a queue to put output data into for the sake of managing the buffer. Since we do not need to let users see their own face on the screen, we may change the root view layer to white. Thus, all of the video capture can be finished at background stage. We create a class called preview layer to present the user interface. We set the video recording view as the root layer on the preview layer. This is the output buffer design and face feature extraction process. Firstly, video streams are required to be converted into frame pictures to be stored. We create one instance of a CV pixel buffer ref to act as a video stream buffer, and create one instance of CF dictionary ref to convert the stored frames into dictionary data. Finally, we create an instance of a CI image to convert this dictionary data into image format. We use all of these instances to manipulate the buffered frames in the buffer and convert video stream into several single frames of pictures. After setting the image operations into a NS dictionary variable, we may execute the facial features detection. After facial features have been extracted, MainView may use these features to control the graphical user interface elements. This is a brief description of the serialization. Thanks for watching.